Trigonometry and Pythagoras. Topic overview. Pythagoras' theorem describes the mathematical relationship between three sides of a right-angled triangle. Pythagoras' theorem states that, in a right-angled triangle, the square of the hypotenuse longest side is equal to the sum of the squares of the other two sides. It is written in the formula, A2 plus B2 equals C2. As well as Pythagoras' theorem, there are other formulae which can be used to calculate unknown side or angle in a triangle, such as trigonometry. Trigonometry is a field of study in mathematics which observes the relationships of the sides and angles of triangles. The trigonometric functions sine, cosine, and tangent, or as they are more commonly known, sin, cos, and tan, can be used to find missing sides or angles of triangles. These functions are defined as the ratios of the different sides of a triangle. The symbol is used to describe an unknown angle. If you know the lengths of two sides of a triangle, you can calculate the value of angle using trigonometry. The functions of sin, cos, and tan can be calculated as follows. Sine function, sin, equals opposite slash hypotenuse. Cosine function, cos, equals adjacent slash hypotenuse. Tangent function, tan, equals opposite slash adjacent. The term SOHCAHTOA is often used by students to remind themselves of these functions. As long as you remember the correct terms for each trigonometric function, you can use them to calculate the values of unknown angles or sides of various triangles. Key concepts. In the new linear GCSE Maths paper, you will be required to solve various mathematical problems involving trigonometry and Pythagoras' theorem. The specific questions you will be expected to answer will vary depending upon which examination board with which you are registered, but as a rule you will be required to use Pythagoras' theorem in 2D and 3D shapes. Use trigonometric functions, the sine rule and the cosine rule to solve various mathematical problems. Calculate the area of a triangle by using 1/2 absync. Listed below are a series of summaries and worked examples to help you solidify your knowledge about trigonometric functions and Pythagoras' theorem. Worked examples. 1. Using Pythagoras' theorem. During your GCSE Maths exam, you will be required to calculate various mathematical problems using Pythagoras' theorem. Example. The following triangle has the values A equals 9 and C equals 15. Calculate the value of side single quote B. Solution. Using Pythagoras' theorem. A2 plus B2 equals C2. 92 plus B2 equals 152. Now all you have to do is solve this expression to find the value of B. B2 equals 255. 81 equals 144. B equals 144 equals 12. 2. Using Pythagoras in 3D shapes, higher tier. If you are sitting the higher tier GCSE Maths exam paper, you may be required to use Pythagoras' theorem to solve problems which involve right-angled triangles within 3D shapes. Example. The following triangle has the values A equals 9 and C equals 15. Calculate the value of side single quote B. Solution. Although this question may appear complex, you can simplify the process using Pythagoras' theorem. Firstly, you must use Pythagoras' theorem in triangle ABC in order to find length AC. AC2 equals AB2 plus BC2. AC2 equals 62 plus 22. AC2 equals 36 plus 4 equals 40. AC equals 40. Now that you know the value of length AC, you can use Pythagoras' theorem in triangle ICF in order to find the length of F. F2 equals AC2 plus CF2. F2 equals 40. 2 plus 32. AF2 equals 40 plus 9 equals 49. AF equals 49 equals 7. Therefore, the length of the diagonal AF equals 7 centimeters. 3. Trigonometry, using sin, cos and tan. As mentioned in the topic overview, you can use the trigonometric functions sin, cos and tan to find the length of the sides of a triangle, the hypotenuse, opposite and adjacent, as well as unknown angles. During your GCSE Maths exam, you will be required to use these trigonometric functions to find the value of an unknown angle. Example: calculate the angle C and state your answer correct to 1 decimal place to 1 dp. Solution: from the diagram above, you know the lengths of the adjacent AC and the hypotenuse BC. Using the phrase SOHCAHTOA, you know that you need to use the cosine function to calculate angle C. Cos C equals 5/7. C equals cos 1 5/7. In order to calculate the value of angle C, you need to calculate the inverse of cos. To do this, type Shift cos 5/7 into your calculator to receive the value of C equals 44.4. During your GCSE Maths exam, you will also be required to use trigonometric functions to calculate the length of one of the sides of a triangle. Example: B. Calculate the length of the side BC. Solution: B. From the diagram above, you know the values of the hypotenuse AB and the angle CAB. The length you are being asked to calculate, BC, is opposite to angle CAB. Using the sentence SOHCAHTOA, you know you need to use the function sin CAB equals BC/AB. Sin 30 equals BC/7. From here, you can solve the expression to calculate the value of length BC. BC equals sin 30/7. Using your calculator, type sin 30 divided by 7 to receive the value of length BC equals 3.5 centimeters. 4. The sine rule. Sine and cosine each have a rule which can be used to find the size of an angle or the length of a side. You may be asked to use these rules during your GCSE Maths exam in order to calculate unknown values. The sine rule is sin A equals sin B equals csinc, or it can be written as sin A equals sin B equals csinc. The sine rule can be used if you know either two of the sides of a triangle as well as an angle which is opposite to one of the two known sides, or one side and any two angles of a triangle. Example: calculate the size of angle R and give your answer correct to 1 decimal place, 1 dp. Solution: using the sine rule, you know that sin 4 equals sin 759. Now you need to solve this expression to find the value of R. Sin R equals sin 75 divided by 9. 4 equals 0.429. Using a calculator, you can work out that R equals shift sin 0.429 equals 25.4. Therefore angle R equals 25.401 dp. 5. The cosine rule. Similarly to the sine rule, you may be required to use the cosine rule during your GCSE Maths exam in order to find the length of a side or size of an angle. The cosine rule is A2 equals B2 plus C2. 2 cosa. However, depending upon your known values, it can also be written as B2 equals A2 plus C2. 2 a cosp. Or as C2 equals A2 plus B2. 2 epcosq. These variations of the cosine rule can also be rearranged into the following rules. Cos A equals B2 plus C2. A22 BC. Cos B equals A2 plus C2. B22 ec. cosc equals A2 plus B2. C22ec. The Cossini rule can be used if you know either two sides in an angle of a triangle or three sides of a triangle but no angles. Example. Calculate the length of the side BC, and give your answer correct to 2 decimal places to 2 dp. Solution. Using the Cossini rule. A2 equals B2 plus C2. 2 cos BC2 equals 72 plus 32. 2, 3, 7 cos 35. Now you need to solve this expression to find the value of the length BC. BC2 equals 58. 42 cos 35. BC2 equals 23.5956. BC equals 23.5956. Therefore, the length of BC equals 4.86 centimeters to 2 dp. 6. Using the side-angle side, SAS, formula to calculate the area of a triangle. Trigonometry can also be used to calculate the area of a triangle. Using the side-angle side, SAS, rule, you can calculate the height of a triangle and use that value to calculate the area of the triangle. The SAS rule is written in the form: area of triangle ABC equals 1/2 ABCNC. This SAS rule can also be rearranged and written as either area of triangle ABC equals 1/2 XNB or area of triangle ABC equals 1/2 BCSN. Note, the SAS rule can only be used if you know two sides of a triangle and the included angle. Example. Calculate the area of the triangle ABC and give your answer correct to 1 decimal place 1 dp. Solution. Using the SAS rule, you know that the area of the triangle ABC is 1/2 AB, AC, sin, cab, so the area of triangle is calculated as ABC equals 1/2 5.2 7.1 sin, 42, equals 12.4. ABC equals 12.4 cm2. Note, when calculating the area of a triangle, remember to present your answer in the correct units of measurement, that is centimeters squared. Exam tips. 1. Memorize Pythagoras theorem. 2. Memorize the term SOHCAHTOA. 3. Remember the sine rule. 4. Remember that the Cossini rule. 5. Memorize the SAS rule for calculating the area of a triangle. 6. Write down all of your working out in order to earn maximum method marks. Topic summary. When revising trigonometry and Pythagoras theorem, your main focus should be memorizing the fundamental principles and formulae. Once you understand and can recall these functions, you can apply a step-by-step process to every trigonometry and Pythagoras question during your actual exam. By doing so, you will substantially increase your chances of scoring higher marks. You should also write down all of your working out. This proof of your method will demonstrate to the examiner who is marking your paper that you have a comprehensive understanding of trigonometric functions and Pythagoras theorem. Moreover, it will provide you with a golden opportunity to quickly double-check your answers and efficiently correct any mistakes you may have otherwise overlooked. Solving equations. Topic overview. When solving an equation, you are trying to find a solution which will make a particular mathematical equation true or correct. For example, x, 3 equals 2. If you put 5 in place of x, 5, 3 equals 2. This solution is true, therefore x equals 5 is the solution of this equation. In the example above, there is only one solution for x. However, during your GCSE Maths exam, you will be asked to solve various equations which have multiple solutions. For example, x minus 4, x minus 3, equals 0, If x is 4, the solution to the equation is 4 minus 4, 4 minus 3, equals 0, equals 0 x1 equals 0. When x is 3, the solution to the equation is 3 minus 4, 3 minus 3, equals 0, equals minus 1 x0 equals 0. Both of these solutions make the results of the equation true, therefore the solutions to this equation are x equals 4 or 3. Key concepts. In the new Linear GCSE Maths paper, you will be required to solve various mathematical equations. The specific questions you will be expected to answer will vary depending upon which examination board with which you are registered, but as a rule you will be required to recognize the different symbols within algebraic equations, manipulate and solve algebraic equations, distinguish the different roles played by letter symbols in algebra using the correct notation. Listed below are a series of summaries and worked examples to help you solidify your knowledge about how to solve different mathematical equations. Worked examples. 1. Using inverses. The most effective methods with which to solve mathematical equations is by using inverses. This involves undoing the steps which the equation is performing in order to find its solution, S. When using inverses, there are several rules which you must follow. Adding and subtracting are the opposite of one another. Multiplying and dividing are the opposite of one another. When using inverses you must perform the same method to both sides of the equation. Example. Solve the equation, x, 8 equals 14. Solution. In order to get x on its own, you must add 8 to both sides of the equation. x8 plus 8 equals 14 plus 8. By adding 8 to both sides, you can get x on its own and find its solution. x8, 8 equals 0, equals 14 plus 8. X equals 14 plus 8. Therefore, x equals 22. Example. B. Solve the equation, 2x plus 9 equals 21 to find the value of x. Solution. B. Get 2x on its own by subtracting 9 from both sides. 2x plus 9, 9, equals 21, 9. 2x equals 12. To work out the value of x, divide both sides by 2. 2x divided by 2 equals 12 divided by 2. Therefore, x equals 6. 2. Solving equations which have unknown values on both sides of the equation. During your GCSE Maths exam, you will also be required to solve an equation which has unknown values on both sides of the equation. Once again, you can use inverses to solve these types of equations and find the solutions of the unknown values. Example. Solve the equation 5x plus 5 equals x plus 13, and find the value of x. Solution. Firstly, you must move all of the x terms onto the same side of the equation. To do this, you will need to subtract x from both sides. 5x, x, plus 5 equals x, x, plus 13. 4x plus 5 equals 13. Now you need to get 4x on its own by subtracting 5 from both sides. 4x plus 5, 5, equals 13, 5. 4x equals 8. Finally, to find the value of x, you must divide both sides by 4. 4x divided by 4 equals 8 divided by 4. Therefore, x equals 2. 3. Solving equations which contain brackets. Some of the equations which you will be asked to solve may include brackets. In these cases, you need to multiply out the brackets before you can solve the equation. Example. Solve the equation 4y plus 3 equals 28 to find the value of y. Solution. Multiply out the brackets. 4y plus 3 equals 28. 4xy plus 4x3 equals 28. 4y plus 12 equals 28. From here, you can use inverses to solve the equation. 4y plus 12 equals 28 12. 4y equals 16. 4y divided by 4 equals 16 divided by 4. Therefore, y equals 4. For working out multiple solutions to an equation, you may also be asked to solve an equation which has multiple solutions. Example. Solve the equation x plus 2x 4 equals 0 to find the value s of x. Solution. Look at each bracket individually and use inverses to find the value s of x. X plus 2 equals 0, x plus 2 equals 0, x plus 2 equals 0 2. Therefore x equals minus 2. 2x 4 equals 0, 2x 4 equals 0, 2x minus 4 plus 4 equals 0 plus 4, 2x equals 4. 2x divided by 2 equals 4 divided by 2. Therefore x equals 2. Therefore, for the equation x plus 2x minus 4 equals 0, x equals 2 or minus 2. Exam tips. 1. When using inverses, always remember that you must perform the same method to both sides of the equation. 2. Remember that adding and subtracting are the opposite of one another. 3. Remember multiplying and dividing are the opposite of one another. 4. When faced with an equation which has multiple solutions, look at each bracket individually and then solve them to find each value. Exam tips. Solving equations is an easy-to-follow process once you understand the basic principles of using inverses. Always remember that if you perform an action to one side, you must perform the same action to the other side of the equation. Moreover, you should always check your solutions by placing the values you have calculated into the equation. If your values give you a true result, you know they are correct. If they do not, you need to go back and solve the equation again. In these cases, it is important that you write down all of your working out. By doing so, you can easily discover where you have gone wrong and correct it. Ultimately, if you practice using inverses, you can quickly become skilled at solving a wide range of mathematical equations. Manipulating expressions. Topic overview. A mathematical expression refers to when numbers, operators and various symbols are grouped together to express, or show, the value of something. For example, 4x9, 5x-6, 4y plus 2x, 3, are all mathematical expressions. When manipulating mathematical expressions, you will encounter various mathematical terms. Equation. An equation is a term used to describe mathematical values which are equal. For example, x plus 3 equals 5. This equation is stating that means that whatever is on the left side of the equals sign, x plus 3, is the same value of that which is on the right side. 5. Variable, constant and coefficient. Within a mathematical equation, there are various different elements to consider. The term variable is used to describe the letter symbol within an equation, for example, x or y. These variable symbols are used because we do not yet know their value. For example, in the equation, 2x plus 3 equals 5, we do not yet know the value of x until we have solved the equation. The term constant is used to describe a number on its own. For example, in the equation 2x plus 3 equals 5, both 3 and 5 are constants because they are not attached to any variables. The term coefficient is used to describe the amount by which a variable must be multiplied. For example, in the equation 2x plus 3 equals 5, 2 is the coefficient, because it tells us that the variable, x, must be multiplied by 2. Key concepts. In the new linear GCSE Maths paper, you will be required to manipulate various mathematical expressions. The specific questions you will be expected to answer will vary depending upon which examination board with which you are registered, but as a rule you will be required to manipulate algebraic expressions by collecting like terms and by taking out common factors, multiplying two linear expressions, factorize quadratic expressions including the difference of two squares, simplify rational expressions. Listed below are a series of summaries and worked examples to help you solidify your knowledge about how to manipulate various mathematical expressions. Worked examples. 1. Collecting like terms. During your GCSE Maths exam, you may be faced with several long algebraic expressions. In these circumstances, you can simplify these expressions by collecting like terms. Example. Simplify the expression 3x plus 7, 4x plus 2 plus 8x minus 6x. Solution. When collecting like terms, you must group together all the x values and all the numbers in order to simplify the expression. 3x plus 7, 4x plus 2 plus 8x minus 6x. All of the x values can be grouped together. 3x, 4x plus 8x, x equals 11x, 5x equals 6x. All of the numbers can be grouped together. 7 plus 2, 6 equals 9, 6 equals 3. Therefore, by collecting like terms, you can simplify the expression 3x plus 7, 4x plus 2 plus 8x minus 6x into 6x plus 3. 2. Taking out common factors. By factorizing an expression, you can simplify it. This process of taking out common factors is the reverse of expanding brackets. Example. Factorize 4y plus 6. Solution. In order to factorize this expression, you must find the highest common factor, HCF, of 4 and 6. When you have done this, you must divide both terms by this number. 4y plus 6 equals 4x, y, plus 6 equals 2x, 2x, y, plus 2x, 3 equals 2x, 2y, plus 2x, 3 equals 2y plus 3. The HCF of 4 and 6 is 2, therefore, 4y plus 6 can be factorized into 2y plus 3. 3. Factorizing quadratic expressions. During your GCSE Maths exam, you will also be required to factorize quadratic expressions. Example. Factorize 5y2 plus 10y. Solution. Much like the previous example, you must find the highest common factor. 5y2 equals 5, y, 10y equals 2, 5, y. As a result, the HCF is 5xy. Therefore, you must divide both values by 5y. Therefore, 5y2 plus 10y can be factorized into 5y, y plus 2. Example. B. Factorize x2 plus 6x plus 8. Solution. In order to factorize this quadratic expression, you must first look for two numbers which add up to make 6 and multiply to make 8. The factor pairs of 8 are 1 and 8, 2 and 4. 2 and 4 add up to make 6. Therefore, you can factor reason to x plus 2, x plus 4. Note, double check your answer by multiplying out the brackets. X plus 2, x plus 4, equals x2 plus 4, x plus 2, x plus 8 equals x2 plus 6, x plus 8. Subsequently, you know that your answer is correct. Example. C. Factorize the expression y2, 5y, 6. Solution. C. First look for common factor pairs which multiply to make -10 and add up to make -3. The factor pairs of -10 are 1 and -6, -1 and 6, 2 and -3, -2 and 3. Out of these common factor pairs, only 1 and -6 add up to make -5. Therefore, you can factor reason to y plus 1, y, 6. Once again, double check your answer by multiplying out the brackets. Y plus 1, y, 6, equals y2. 6y plus y, 6 equals y2. 5y, 6. For factorizing the difference of two squares. During your exam, you may also be required to factorize an expression which does not have an x term, for example, x2, 9. In these circumstances, you must use the same factorization method as previously demonstrated, with the exception that you must look for two numbers which will multiply to make 9 and add to make 0. Example. A. Factorize x2, 9. Solution. A. You need to find two numbers which will multiply to make 9 and add to make 0. The common factor pairs for 9 are 1 and -9, -1 and 9, 3 and -3. Out of these common factor pairs, only 3 and -3 will add up to make 0. Therefore, this can be factorized into x plus 3, x, 3. Note, not all quadratic expressions without an x term can be factorized. For example, x2, 49, will factorize into x plus 7, x, 7. However, x2 plus 49 will not factorize. It is important to remember that, in all examples which will factorize, you must have x circumflex to minus a square number. The term which is used to describe the factorization of these expressions is called the difference of two squares. Exam tips. 1. When collecting like terms, you must group together all the x values and all the numbers in order to simplify the expression. 2. In order to factorize an expression, you must find the highest common factor, HCF, of the values within the expression. When you have done this, you must divide both terms by this number. This process is the reverse of expanding out the brackets. 3. When factorizing quadratic expressions, look for two values which will add up to make the coefficient of the x term and which will multiply to make the value of the constant within the expression. 4. When factorizing the difference of two squares, remember that, in all examples which will factorize, you must have x circumflex to minus a square number. Topic summary. Once you understand the basic principles of manipulating expressions, you will easily be able to factorize and simplify a variety of different expressions. Always remember to double-check your answer by multiplying the brackets. By doing so, you can know for sure whether your answer is correct, and if it is not, you can quickly go back and work out the right answer. Above all else, write down all of your working out. This will help you to identify if you have made a mistake and correct it. It will also enable the examiner who is marking your paper to award you the maximum method marks for each question. Change the subject of a formula. Topic overview. A formula is a type of equation which shows the relationship between different variables such as x and y. For an equation to be a formula, it must have more than one variable. For example, x plus y equals 7 is a formula because it shows the relationship between x and y, whereas 2x 8 equals 0 is not a formula because it only has one variable, x. The subject of a formula is the single variable to which everything else in the formula is equal. The subject of a formula will usually be positioned to the left of the equals sign. For example, x equals 2y plus 4z. In this example, x is the subject of the formula because everything else is equal to it. Using the mathematical principles which are demonstrated in the worked examples below, you can rearrange a formula in order to make another variable the subject. Key concepts. In the new linear GCSE Maths paper, you will be required to solve various mathematical problems related to formulae and their subject. The specific questions you will be expected to answer will vary depending upon which examination board with which you are registered, but as a rule you will be required to recognize the properties of a formula, substitute numbers into a formula, change the subject of a formula. Listed below are a series of summaries and worked examples to help you solidify your knowledge about how to change the subject of a formula. Worked examples. When using mathematical formulae. During your GCSE Maths exam, you may be required to construct mathematical formulae out of various data. Example. A DVD rental company charges 50 pence per day to rent a film, plus an initial fixed price of £1. Write a mathematical formula for the cost of renting a C for n number of days. Solution. The question has given you all the information you need in order to construct a formula. The cost, C, of renting a day is the initial fixed charge, £1, plus a 50 pence charge for a non-specified number of days, n. This information can be written as cost equals initial fixed price of £1, plus 50 pence charge x number of days rented. Therefore, as a formula, this information can be written as C equals £1 plus n x 50 pence, to substituting numbers into a formula. After you have constructed a formula, you may be asked to use it to solve various questions. These questions will often involve substituting numbers into the formula. Example. Using the formula you have just constructed, work out the cost of renting a DVD for 22 days. Solution. To work out how much it would cost to rent a DVD for 22 days, you substitute the value 22 into the variable n, which represents number of days rented. Therefore, C equals £1 plus n x 50 pence. C equals £1 plus 22x 50 pence. C equals £1 plus £11. C equals £12. Therefore, it would cost £12 to rent a DVD for 22 days. 3. Changing the subject of a formula. Once you have understood the basic principles of mathematical formulae, you can tackle more complex problems such as hanging the subject of a formula. Changing the subject of a formula is very similar to using inverses to solve mathematical equations. Therefore, you must remember the following rules. Adding and subtracting are the opposite of one another. Multiplying and dividing are the opposite of one another. When using inverses, you must perform the same method to both sides of the equation. Example. Make x the subject of the formula. Z equals 4x plus 4y. Solution. To make x the subject of this formula, first you must move 4y to the other side of the equals sign. Z-4y equals 4x plus 4y dash 4y. Z minus 4y equals 4x. Now you need to get x on its own, so you must divide both sides by 4. By doing so, you have changed the subject of the formula from z to x. 4x divided by 4 equals z4y divided by 4. X equals z minus 4y slash 4. Example B. Make Q the subject of the formula. P equals 4/7, Q 28. Solution B. When you have to change the subject of a formula which includes a fraction, you must first multiply both sides of the formula by the denominator of the fraction to get rid of it. Px7 equals 4/7, Q 28, x7. 7p equals 4, Q 28. Next you must expand the brackets on the right-hand side of the formula. 7p equals 4q 112. From here, you can get 4q on its own and divide to get q. 7p plus 112 equals 4q. Q equals 7p plus 112 slash 4. Example C. Make B the subject of the formula. C equals B2/8. Solution C. Multiply both sides by 8. 8. C equals B2. Take square roots to get B on its own. B equals 8. C. Example D. Make A the subject of the formula. S equals A plus half at 2. Solution D. First subtract A from both sides. S A equals half at 2. Then multiply both sides by 2 to get rid of the fraction. At 2 equals 2, S A. Finally, divide both sides by T2 to get A on its own. At 2 divided by T2 equals 2, S A divided by T2. A equals 2, S A slash T2. Exam tips. 1. When changing the subject of a formula, use the rules of inverses. Always remember that you must perform the same method to both sides of the equation. 2. Remember that adding and subtracting are the opposite of one another. 3. Remember multiplying and dividing are the opposite of one another. 4. When faced with an equation which has multiple solutions, look at each bracket individually and then solve them to find each value. 5. When you have to change the subject of a formula which includes a fraction, you must first multiply both sides of the formula by the denominator of the fraction to get rid of it. Topic summary. Once you have a strong understanding of the fundamental properties of mathematical formulae, you can begin to confidently apply this knowledge to more complex problems. When constructing and substituting values into different formulae, it is crucial that you write down all of your working out. This is because, even if you write down an incorrect formula, if you substitute values into it using the correct process, you can still earn vital method marks. Moreover, if you write down all of your working out, then you are more likely to notice any mistakes you have made and then correct them. Seemingly small points such as these can make the difference between a B and a grade. Indices. Topic overview. An index, or the plural, indices, refers to a sequential arrangement of numbers. In order to understand and use indices, you must first understand the basic principles of squared numbers, cubed numbers, and their roots. A squared number is displayed as 42. This means that the number 4 is squared, or 4 by 4. The small 2 is referred to as an index number, or power. It is this small number which tells you how many times you must multiply the main value, in this case 4, by itself. This series of numbers are known as square numbers. These are the values which you get when you multiply an integer by itself. For example, the first 5 square numbers are as follows: 12 equals 1, 22 equals 4, 32 equals 9, 42 equals 16, 52 equals 25. The opposite of a square number is a square root. The square root of a number is often denoted by this symbol. Therefore, if you are asked to work out the square root of 4, it will be denoted by the following symbol: 4 equals 2. However, when you square either a positive or negative value, you will always receive a positive result. For example, minus 2x2 equals 4. Therefore, 4 equals plus minus sine 2. It is important to remember that every number has 2 square roots. As well as squaring a number, you can also cube a number. A cubed number is displayed as 83 and means that the number has been cubed, or 8x8x8. Similarly to square numbers, there are also cube numbers. The first 5 cube numbers are as follows: 13 equals 1, 23 equals 8, 33 equals 27, 43 equals 64, 53 equals 125. Similarly to square roots, the opposite of a cube number is known as a cube root, which is denoted using the following symbol: 3. Therefore, 8. 3 equals 2. However, unlike squared numbers, each number only has one cube root. In the new Linear GCSE Maths paper, you will be required to work out several problems involving indices. According to the Edexcel revision checklist for the Linear GCSE Maths paper, you will be required to use index notation for squares, cubes and powers of 10, use index laws for multiplication and division of integer, fractional and negative powers, interpret, order and calculate with numbers written in standard index form. Listed below are a series of summaries and worked examples to help you solidify your knowledge about indices. 1. Rules of indices. Once you have a basic understanding of squared and cubed numbers, you can perform operations on these values. When multiplying and dividing and working out the power of a power, you must follow the 3 rules of indices. Multiplying. When multiplying indices, you add the values of the powers. Example. A. Calculate. 33, 35. Solution. A. 33, 35 equals 3, 3, 3, 3, 3, 3, 3, 3, 3 plus 5 equals 8. 33, 35 equals 38. 38 equals 6,561. Dividing. Alternatively, when dividing indices you subtract the values of the powers. Example. B. Calculate. 35 plus 33. Solution. B. 35 33rds equals 3, 3, 3, 3, 3, slash 3, 3, 3, therefore you cancel out 2 of the 3 seconds because 5 minus 3 equals 2. Therefore, 35 divided by 33 equals 32 equals 9. The power of a power. When taking the power of a number which has already been raised to a power, you must multiply the values of these powers. Example. C. Calculate. 33, 2. Solution. C. In this question, you are being asked to calculate the square of 33. To calculate this, you multiply the powers. 33, 2 equals 3, 3, 3, 3, 3, 3 equals 36. The answer has an index of 6, which is the result of multiplying the powers at the beginning. 3, 2 equals 6. Therefore, 33, 2 equals 36 equals 729. 2, 0. Negative and fractional powers. During your exam, you may be asked to work out 0, negative and fractional powers. In order to do so correctly, you must follow the specific rules which apply to these powers. 1. Anything raised to the power of 0 is equal to 1. For example, 10 equals 1, 20 equals 1, 30 equals 1. 2. Anything raised to the power of a negative value is 1 For example, 2 equals 12, 2 equals 14. 3. 4 equals 13, 4 equals 181. 3. Anything raised to the power of a fractional value is the root of that value, or a 1/2 equals a 1/3 equals a 3. Example. Calculate 41 halves. Solution. 41 divided by 2 equals 4, equals 2. Example. B. Calculate 271 thirds. Solution. B. 271 divided by 3 equals 27, 3 equals 3. Exam tips. 1. Remember that when multiplying indices, you add the powers. 2. When dividing indices, remember that you subtract the powers. 3. When taking the power of a number which has already been raised to a power, you must multiply the values of these powers. 4. Any value raised to the power of 0 is equal to 1. 5. Any value raised to the power of a negative value is 1/a circumflex b. 6. Any value raised to the power of a fractional value is the root of that value. Topic summary. Ultimately, once you have memorized the fundamental rules of indices, you will be able to easily calculate the answers to any indices-related questions during your GCSE Maths exam. Also, it is extremely important that you clearly display all of your working out. By doing so, you can earn valuable method marks which can make a significant difference to your overall grade. Standard form. Topic overview. Standard form, or standard index form as it is often known, is a very useful mathematical process when you need to write very large or very small numbers. In standard form, a number is always written in the format a 10n. In this format, a is always between 1 and 10 and n tells you how many places you need to move the decimal point. For example, a very large number such as 500,000 would be written in the form 5x105. In this example, n is 5 because we need to move the decimal point 5 places to the left so that a is more than 1 but less than 10. Similarly, a very small number such as 0.09292 would be written in the form 9.2x10-2. In this example, n is -2 because we need to move the decimal point 2 places to the right so that a is more than 1 but less than 10. Key concepts. In the new linear GCSE Maths paper, you will be required to work out several problems involving standard form. According to the Edexcel revision checklist for the linear GCSE Maths paper, you will be required to approximate to specified or appropriate degrees of accuracy including a given power of 10, number of decimal places and significant figures. Use a calculator effectively and efficiently. Listed below are a series of summaries and worked examples to help you solidify your knowledge about standard form. 1. How to write numbers in standard form. As mentioned in the topic overview, standard form is used to write very large or very small numbers. During your exam, you will be asked to write a series of very large or very small numbers in standard form. Example. Write 37,000,000 in standard form. Solution. Using the format x10n, you can write 37,000 as 3.7 10 million. This can be rewritten as 3.7 10 10 10 10 10 10 10 equals 3.7 107. Therefore 37 million written in standard form, 3.7 107. You may also be asked to convert numbers which have been written in standard form back to ordinary numbers. Example: B. Convert 5.9 104 back from standard form. Solution: B. 5.9 104 equals 5.9 10,000 equals 59,000. Therefore, when converted back from standard form, 5.9 104 equals 59,000. 2. Adding and subtracting numbers in standard form. There is a simple process which you can follow when adding and subtracting numbers in standard form. Convert the values in question into ordinary numbers. Do the calculation. Change the answer back into standard form using the format AX10 circumflex n. Example: calculate 3.6 104 plus 9.48 105. Solution: convert the values into ordinary numbers. 36,000 plus 948,000 equals 984,000. Change the answer back into standard form using the format *10 circumflex n. 984,000 equals 9.84 105. Therefore, 3.6 104 plus 9.48 105 equals 9.84 105. 3. Multiplying and dividing numbers in standard form. When multiplying and dividing numbers which are in standard form, you can use the fundamental rules for multiplying and dividing powers. When multiplying powers, you add the values. For example, 104, 103 equals 107. When dividing powers, you subtract the values. For example, 106 divided by 104 equals 106. 4 equals 102. Example: simplify. 4 105. 2 104. Solution: multiply 4 by 2 and add the powers of 10. 4 105. 2 104 equals 4. 2 105 plus 4 equals 8. 109. Therefore, 4 105. 2 104 can be simplified to 8 109. Example: B. Simplify 45 106 slash 9 102. Solution: B. Divide 45 by 9 and subtract the powers of 10. 45 106 divided by 9 102 equals 45 ninths. 106. 2 equals 5 104. Therefore, 45 106 slash 9 102 can be simplified to 5 104. 4. Calculator standard form. It is important that you know how to enter standard form into your calculator. The exp button on your calculator is used for entering exponents into your calculator. An exponent is the term used to describe numbers which have been multiplied by a certain power of 10. During the calculator paper of your maths exam, you may be required to enter numbers into your calculator in standard form. To do this, follow the process below. Enter the number 4 times 10 circumflex 15 on your calculator by typing in 4 exp 15 equals This will enter the value into your calculator in correct standard form. This process can be highly useful if you are asked to make multiple calculations of very large or very small numbers. Exam tips. 1. Memorize the format x10 circumflex n. Once you understand this format, you can easily apply it to any standard form exam question. 2. Always double-check your answers and count the number of decimal places. 3. Remember that when multiplying you add the powers and when dividing you subtract the powers. 4. Before setting the calculator paper, check that your calculator is functioning properly and contains new batteries. 5. Write down all of your working out in order to score maximum method marks. Topic overview. Once you understand the basic principles of standard form, you will see that it is actually a simple and a highly useful process. As long as you correctly place the decimal point and double-check your working, standard form can be a great topic through which you can earn plenty of marks. Polygons. A polygon is the mathematical term used to describe a two-dimensional, 2D, closed shape with straight sides. The term polygon is Greek, with poly meaning many, and gon meaning angle. Polygons can either be regular or irregular. If all of the angles of a 2D shape are equal and all the sides are equal, then it is regular polygon. If the angles are not equal and the sides are not equal, then the shape is an irregular polygon. You can also have concave or convex polygons. A convex polygon is a 2D shape which has no angles pointing inwards. With a convex polygon, none of the internal angles can be more than 180 degrees. Alternatively, if any internal angle is more than 180 degrees, then the polygon is concave. There are also simple and complex polygons. A simple polygon only has one boundary, and does not cross over itself. Conversely, a complex polygon will intersect itself and therefore has more than one boundary. For example, key concepts. In the new linear GCSE Maths paper, you will be required to solve various mathematical problems involving polygons. The specific questions you will be expected to answer will vary depending upon which examination board with which you are registered, but as a rule you will be required to calculate and use the sums of the interior and exterior angles of polygons. Recognize the properties and definitions of special types of quadrilaterals including a square, rectangle, parallelogram, trapezium, kite and rhombus. Understand and use the angle properties of lines, triangles, and quadrilaterals. Listed below are a series of summaries and worked examples to help you solidify your knowledge about polygons. Worked examples. 1. Angle properties of triangles. A triangle is a three-sided polygon. The angles within a triangle add up to 180 degrees. Angles on a straight line also add up to 180 degrees. As a result, there is a rule which applies to all triangles. The exterior angle is equal to the sum of the two opposite interior angles. This rule can be explained by looking at the diagram below. From the diagram, we know that angles A, B, and C all add up to 180 degrees because they are all of the angles within the triangle. A plus B plus C equals 180. We also know that angles C and D add up to 180 degrees because they are all the angles on the straight line. C plus D equals 180. By rearranging both equations, subtract C from both sides, you are presented with A plus B equals 180, C. D equals 180, C. A plus B equals D. As a result, you know that the exterior angle, D, is equal to the sum of the two opposite interior angles, A and B, because they are both equal to 180 degrees, C. During your GCSE Maths exam, you will be required to use these rules to solve various mathematical problems. Example: A. Find the values of x and y in the following triangle. Solution: A. Using the rule that the sum of the two opposite interior angles equals the exterior angle, you know that x plus 50 equals 92. From here, you can solve the equation to find x. X equals 92, 50 equals 42. Similarly, by using the rule that all the angles in a triangle add up to 180 degrees, you know that y plus 42 plus 50 equals 180. From here, you can solve the equation to find y. Y equals 180, 50, 42 equals 180, 92 equals 88. Therefore, x equals 42 degrees and y equals 88 degrees. 2. Angle properties of quadrilaterals. A quadrilateral is a four-sided polygon. All of the angles within a quadrilateral add up to 360 superscript O. There are several types of quadrilateral, each with different properties. Square. A square is a regular quadrilateral, that is, all of its sides are of equal length, all of its angles are equal, 90 degrees. Similarly, all of its sides are of equal length. The opposite sides of a square are parallel. The diagonals of a square bisect one another at 90 degrees and are equal in length. A square has four lines of symmetry. Rhombus. All of the sides of a rhombus are of equal length. Its opposite sides are parallel. Its diagonally opposite angles are equal. Its diagonals bisect one another at 90 degrees. A rhombus has two lines of symmetry. Rectangle. All of the angles in a rectangle are equal, 90 degrees. Its opposite sides are of equal length and are parallel. Its diagonals bisect one another. Its diagonals are equal in length. A rectangle has two lines of symmetry. Parallelogram. A parallelogram has no lines of symmetry. Its diagonally opposite angles are equal. Its opposite sides are of equal length and are parallel. Its diagonals bisect one another. Trapezium. A trapezium has no lines of symmetry and has no rotational symmetry. One pair of a trapezium's opposite sides is parallel. Kite. A kite has one line of symmetry and no rotational symmetry. Two pairs of its sides are of equal length. One pair of its diagonally opposite angles is equal. Only one of its diagonals is bisected by the other. A kite's diagonals cross at 90 degrees. During your GCSE Maths exam, you will be required to recognize and identify the properties of these different types of quadrilateral. 3. Interior angles of polygons. An interior angle is an angle inside a polygon. The interior angles within different polygons add up to different amounts. For example, as mentioned in the previous sections, the interior angles of a triangle add up to 180 degrees and the interior angles of a quadrilateral add up to 360 degrees. As a rule, every time a side is added to a polygon, another 180 degrees is added to the interior angle total. The following polygon table demonstrates this rule. This rule can be written as sum of interior angles equals n2 times 180 degrees. If a polygon is regular, that is, all of its sides are of equal length and all of its angles are of equal size, then the following rule is true. Each interior angle of a regular polygon equals n2 times 180 degrees / n, where n refers to the number of sides. During your GCSE Maths exam, you will be required to use these rules to answer a series of polygon-related problems. Example. Calculate the sum of the interior angles of a regular octagon and the sides of each interior angle. Solution. An octagon has 8 sides. As a result, the sum of its interior angles will be n 2 180 8 2 180 equals 6 180 equals 1080. As mentioned in the question, it is a regular octagon, so all of its angles will be of equal size. Consequently, in order to calculate the size of each interior angle, you can divide the sum of its interior angles by 8, 1080, divided by 8 equals 135. Therefore, the sum of the interior angles in a regular octagon is 1080 degrees and the size of each interior angle is 135 degrees. 4. Exterior angles of polygons. The exterior angle of a polygon is an angle between any side of a shape and a line extended from the next side. When you add the exterior angle of a polygon and its corresponding an exterior angle on a straight line, it amounts to 180 degrees. As a rule, the sum of the exterior angles of a simple polygon add up to 360 degrees. This is referred to as a full revolution. The exterior angle of a polygon and its corresponding interior angle always add up to 180 degrees. This is due to the fact that the two corresponding angles create a straight line. In order to calculate the exterior angle of a regular polygon, you adhere to the following rule. Exterior angle of a regular polygon equals 360 degrees divided by number of sides. This is due to the fact that the exterior angles of a regular polygon always add up to 360 degrees. During your GCSE Maths exam, you may be required to use these rules to solve various problems. Example. The interior angles of a regular polygon are each 120 degrees. Calculate the number of sides. Solution. The question tells you that the interior angles of a regular polygon are 120 degrees. As a result, you can calculate the exterior angles. Seeing as an interior angle and its corresponding exterior angle add up to 180 degrees, the sides of the exterior angles of this regular polygon, 180, 120, equals 60. By using the rule that the exterior angles of all polygons add up to 360 degrees, you can use this rule to calculate the number of sides. Exterior angle of a regular polygon equals 360 degrees divided by number of sides. Therefore, number of sides equals 360 degrees divided by exterior angle equals 360 degrees divided by 60 degrees equals 6. Therefore, this regular polygon has 6 sides, that is, it is a hexagon. Exam tips. 1. Remember that all of the sides of regular polygon and all of its angles are equal. 2. Memorize the rule that an interior angle and its corresponding angle add up to 180 degrees, and that all of the exterior angles of a polygon add up to 360 degrees. 3. Remember that every time a side is added to a polygon, another 180 degrees is added to the interior angle total. 4. Memorize the rule that the sum of the interior angles of a polygon equals n2 times 180 degrees, and that each interior angle of a regular polygon can be calculated by the rule n2 times 180 degrees /n, where n refers to the number of sides. Topic summary. When revising the topic of polygons, it is highly recommended that you memorize the properties of different types of polygons, as well as their names. For example, as well as memorizing the properties of triangles and quadrilaterals, Also try to recall the names of larger polygons, such as 7-sided heptagons, 8-sided octagons, 9-sided nonagons, and 10-sided decagons. If you can easily recognize and recall the names and properties of both simple and complex polygons, you will be able to tackle polygon-related exam questions quickly and confidently. Congruent triangles. Topic overview. If two or more shapes are described as congruent, it means that they are identical in shape and size. Shapes can be congruent even if one of the shapes has been reflected or rotated. Consequently, when two or more triangles are described as congruent, it means that they have exactly the same three sides and exactly the same three angles. These triangles can be congruent even if one of them has been reflected or rotated. For example, the triangles below are congruent because they have exactly the same sides and angles. However, it is important to note that triangles can have exactly the same angles but not be congruent. Triangles can only be congruent if all of their sides are exactly the same length. Their angles may be the same also, but it is not necessary. For example, the triangles displayed below have exactly the same angles but are not congruent because their sides are different lengths. Is not congruent to. There is a specific way of marking triangles in order to demonstrate that they are congruent. In the diagram, the sides which are marked with one line are equal in length to one another respectively. Similarly, the sides which are marked with two lines are equal in length to one another, and the sides marked with three lines are equal in length to one another. Using the same method, the angles marked with one arc are equal to one another respectively, as are the angles which are marked with two arcs and the angles which are marked with three arcs. It is also helpful to refresh your knowledge of the different types of triangle in order to effectively calculate various measurements of congruent triangles. An equilateral triangle has three equal sides and three equal angles which are always 60 degrees. An isosceles triangle has two equal sides and two equal angles. A scalene triangle has no equal sides and no equal angles. Key concepts. In the new linear GCSE Maths paper, you will be required to solve various mathematical problems involving congruent triangles. The specific questions you will be expected to answer will vary depending upon which examination board with which you are registered, but as a rule you will be required to understand congruence and similarity. Use the principles of congruent triangles to solve various mathematical problems. Listed below are a series of summaries and worked examples to help you solidify your knowledge about congruent triangles. Worked examples. During your GCSE Maths exam, you will be required to prove whether two triangles are congruent. You may also be required to solve various mathematical problems using the principles of congruent shapes. Two or more triangles are congruent if one of the following rules applies. 1. The side-side-side rule. Often referred to as the SSS rule, the side-side-side rule can be used to prove two triangles are congruent. If the three sides of the first triangle are equal to the three sides of the second triangle, then the triangles are congruent to one another. You can mark these SSS triangles in the following manner. 2. The side-angle-side rule. Often referred to as the SAS rule, the side-angle-side rule can be used to prove two triangles are congruent. If two sides of the first triangle are equal to two sides of the second triangle, and the included angle is equal, then the two triangles are congruent. You can mark these SAS triangles in the following manner. 3. The angle-angle-side rule. Often referred to as the AS rule, the angle-angle-side rule can be used to prove two triangles are congruent. If two angles of the first triangle are equal to two angles of the second triangle, and one similarly located side is equal, then the two triangles are congruent. You can mark these as triangles in the following manner. 4. The right-angled hypotenuse side rule. Often referred to as the RHS rule, the right-angled hypotenuse side rule is only applicable to right-angled triangles. If the hypotenuse and one other side of the first right-angled triangle are equal to the hypotenuse and corresponding side of the second right-angled triangle, then the two triangles are congruent. You can mark these RHS triangles in the following manner. All of these rules can be used to prove whether triangles are congruent, as well as to calculate various measurements relating to two triangles. Example. Given that these two triangles are congruent, calculate the perimeter of triangles these. Solution. As well as using the rules of congruence, this question also requires you to recognize and recall the properties of various triangles. If these two triangles are congruent, all of their angles will be the same. Therefore, triangle Z has two 72 degrees angles and one 36 degrees angle. 36 degrees plus 72 degrees plus 72 degrees equals 180 degrees. Both triangles have two equal angles, and as such they must both be isosceles triangles. Given that an isosceles triangle has two equal angles and two equal lengths, and given that these two triangles are congruent, triangles Z must have side lengths of Z equals 5.7 centimeters, XZ equals 5.7 centimeters, YZ equals 3.7 centimeters. Therefore the perimeter of Z equals 5.7 plus 5.7 plus 3.7 equals 15.1 centimeters. Example. B. Given that side QP is parallel and equal in length to side RS, which angle in triangle PO corresponds to angle OSR in triangle SOR? Solution. B. From the question, you know that side QP is parallel and equal in length to side RS. As a result, angles OP and RS are alternate angles and therefore equal. Due to these factors, the angles PO and angle SOR must be vertically opposite and are therefore equal. This also means that angles OP and OSR are also alternate angles and therefore equal. Subsequently, two sides and one angle of the corresponding triangles are equal. Using the SAS rule, these two triangles are congruent. Not only does this prove that these triangles are congruent, but it also proves that angle OP corresponds to angle OSR, as illustrated in the diagram below. Exam tips. 1. Remember that, in order for triangles to be congruent, they must have exactly the same sides, and exactly the same angles. 2. Memorize the different rules which can be used to prove triangles are congruent. For example, the SSS rule, which requires three sides of the first triangle to be equal to the three sides of the second triangle. 3. Memorize the side angle side rule to prove the two triangles are congruent. If two sides of the first triangle are equal to two sides of the second triangle, and the included angle is equal, then the two triangles are congruent. 4. Memorize the angle side rule to prove two triangles are congruent. If two angles of the first triangle are equal to two angles of the second triangle, and one similarly located side is equal, then the two triangles are congruent. 5. Remember that the RHS rule is only applicable to right-angled triangles. If the hypotenuse and one other side of the first triangle are equal to the hypotenuse and corresponding side of the second triangle, then the two right-angled triangles are congruent. Topic summary. Recognizing and proving that triangles are congruent is dependent upon your ability to memorize the various SAS, SSS, OS and RHS rules, as well as the general properties of different types of triangles. If you can confidently recall these mathematical principles, you will be able to effectively prove whether two or more triangles are congruent. Once you are able to prove whether triangles are congruent, you will also be able to use the rules of congruence in order to calculate various measurements regarding these triangles. When solving exam problems involving congruent triangles, it is important that you write down all of your working out. This includes writing down the definition of the specific rule of congruence which you are using. By doing so, even if you calculate an incorrect answer, you will earn valuable method marks because you have demonstrated that you understand the rules of congruent triangles. Construction and Loci problems. Topic overview. In the field of mathematics, construction means to draw shapes, angles or lines accurately. These constructions require you to use a compass, a ruler and a pencil. For example, during your GCSE Maths exam, you may be required to construct a triangle. There are two methods of drawing triangles, with a compass or by using a ruler and protractor. Example. Construct a triangle with side lengths of 3 cm, 4 cm and 5 cm. Solution. Method 1. Using a compass. Firstly, use your ruler to draw a 5 cm line. Label either end of this line point A and point B. Secondly, open your compass to a radius of 4 cm and place the compass needle at point A using this radius of 4 cm. Draw an arcade. Then, place your compass on point B and draw a similar arcade. Find the point where these two arcs cross and join each end of the line to this point where they cross. Note, do not erase any construction arcs when using this method, in order to demonstrate your method to the examiner who is marking your paper. Example. B. Construct a triangle which has one side length of 6 cm, and two angles of 55 degrees and 70 degrees. Solution. B. Method 2. Using a ruler and protractor. When you are asked to construct a triangle and the question tells you the size of some of its angles, it is often easier to use a ruler and protractor as opposed to a compass. Firstly, use a ruler to draw 6 cm and label either end of this line point A and point B. Secondly, place the center of your protractor on point A and line up your protractor at 0 degrees. From this point, measure an angle of 55 degrees and mark it with a dot. Connect this dot to point A with a ruler. Similarly, place your protractor on point B, line it up with 0 degrees, measure an angle of 70 degrees and mark it with a dot. Connect this dot to point B with a ruler and it should meet with the line you have drawn from point A. A locus is a path which is formed by a point which moves according to a specific principle or rule. The plural of locus is loci, and is used to describe a set of all points which share a property. When connected, these points will create a circle. For example, if you connect all of the points on the grid below, you will create a circle. Key concepts. In the new linear GCSE Maths paper, you will be required to solve various construction problems. The specific questions you will be expected to answer will vary depending upon which examination board with which you are registered, but as a rule you will be required to use a straight edge and a pair of compasses to draw constructions. Construct loci and solve mathematical problems using loci. Listed below are a series of summaries and worked examples to help you solidify your knowledge about constructions and loci. Worked examples. 1. Perpendicular bisector of a line segment. During your GCSE Maths exam, you may be required to construct the perpendicular bisector of a line segment. The perpendicular bisector of a line segment is the locus of a point which moves in an equal distance from 2 points, A and B. Perpendicular is the mathematical term used to describe lines which are at right angles to one another. Bisector is a mathematical term meaning to cut in half. Example. Construct the perpendicular bisector to the line AB. Solution. In order to construct this locus, you must follow these steps. Firstly, draw a straight horizontal line and label either end as points A and B respectively. Secondly, place your compass on point A and extend your compass so that it is positioned halfway along the line. Using your compass, draw an arc along this halfway point. Whilst keeping your compass extended to this length, position your compass on point B and draw an arc halfway along the line. Locate the 2 points where these arcs intersect and label them as points C and D. Draw a straight line through these points C and D and you will have constructed the perpendicular bisector to the line AB. Note, you can check that your answer is correct by measuring the angle between line AB and line CD. If this angle is 90 degrees, then the two lines are perpendicular. 2. How to bisect an angle. If you are asked to bisect an angle, this means that you are being asked to cut the angle in half. You can bisect an angle by following this method. Example. Bisect the angle PQR. Solution. Firstly, place your compass on the point Q and draw an arc which crosses both sides of the angle. Label these points A and B. Secondly, place your compass on point A and draw an arc between the two sides of the angle. Without changing the extension of your compass, place it on point B and draw an arc between the two sides of the angle. Locate the point where these two arcs cross and label it point C. Finally, draw a line through point Q and point C. This line Quebec will bisect the angle in question. Note, in order to check your answer is correct, measure the two angles either side of line XC. If you have correctly bisected the angle, these two angles will be of equal size. Asterisk 3. Solving Loci problems. Asterisk as mentioned in the topic overview, when a point moves in a plane according to a series of given conditions, the path along which it moves is referred to as a locus. The term loci is the plural of locus. During your GCSE Maths exam, you may be required to solve various problems involving loci. Example. Construct the locus of a point P at a constant distance of 3 cm from a fixed point Q. Solution. In order to construct this locus, measure and draw a 3 cm line. Label either side of the line as points P and Q respectively. Extend your compass to 3 cm and place the needle of your compass on point Q. Draw a full circle around point Q. This circle should cross point P. Example. B. 2 cows graze within a field which has a length of 20 meters and a width of 12 meters. The cows are penned within diagonally opposite corners of the field, which have lengths of 13 meters. On a drawing which is sketched to scale, demonstrate the sections of the field which are grazed by both cows. Solution. B. The question has stated that your drawing must be sketched to scale. An appropriate scale would be 2 meters equals 1 centimeters. As a result, you must adapt your measurements to fit this scale. 20 meters equals 10 centimeters, 12 meters equals 6 centimeters, 13 meters equals 6.5 centimeters. Once you have set the scale, you need to measure a distance of 6.5 centimeters using your compass. To do this, place your compass point on one corner of the rectangle, and draw an arcade. Repeat this process for the diagonally opposite corner. As a result, the area in between these two arcs will be grazed by both cows. It is helpful if you shade in this area where both cows graze. Exam tips. 1. Always sharpen your pencil before constructing shapes and loci. This will make your answers more accurate. 2. Double-check all of your constructions by measuring the angles and lengths you have constructed. 3. Do not erase any of your construction markings because they will earn you valuable method marks during your exam. 4. Remember that all the loci of a particular point will form a circle once connected. This rule can be used to check that you have correctly constructed particular loci. Topic summary. The GCSE Maths topics of construction problems in loci is highly dependent upon accuracy. As a result, you need to make sure you bring the correct equipment into the examination with you. Remember to bring a compass, a ruler, a protractor, a sharpened pencil. It is also advisable that you bring a spare pencil, a pencil sharpener, a rubber. If you bring this necessary equipment, you can correctly sketch accurate shapes, loci, and bisect angles. Moreover, sketching constructions and solving loci problems is greatly aided by practice. Therefore, if you attempt as many past paper questions as possible, you will become confident at this topic and earn the maximum number of marks in your actual GCSE exam. Transformations. Topic overview. In mathematics, transforming an object means that you change its appearance. During your GCSE Maths exam, you will be required to recognize and perform 4 different types of transformation on various shapes. The 4 types of transformations which you will encounter during this topic are rotation, reflection, translation, enlargement/resizing. With the exception of enlargement/resizing, transformations such as rotation, reflection and translation will not alter the size of the shape. After these transformations, the shape will still have exactly the same size, area, angle sizes and line lengths. When transforming a shape, the original shape is called object, and the transformed shape is called the image. If the shape in question has been rotated, reflected or translated, it will remain the same size. As a result, the transformed image would be congruent to the original object. However, if the shape in question is enlarged or resized, it will change in size. As a result, the transformed image would be similar to the original object. For more information on congruence and similarity, see the Congruent Triangles Revision Guide. Key concepts. In the new linear GCSE Maths paper, you will be required to solve various transformation questions. The specific questions you will be expected to answer will vary depending upon which examination board with which you are registered, but as a rule you will be required to